Hello, my name is Richard Kent. Today I'd like to talk about how we balance. Now, it's really important we balance, we take it all for granted, but actually balance is one of the most complicated things that we will learn to do. Children, when they're little babies, they have to learn to balance so they can stand up. And you notice when children first start to walk, they have difficulty balancing because it actually involves all of the various different systems in our bodies. It involves the skeletal system, our central nervous system, it involves our eyesight, it involves the sensations we get from our hands and our feet, and also in particular involves our gyroscope, effectively, the semicircular canals in our middle ear. So I want to concentrate now on these semicircular canals. There are 3 of them in 3 different planes, and they're very, very cleverly designed. Effectively, they actually are like gyroscopes. They're made in 3 planes, and in the center of each semicircular canal is fluid, which as you move around, as we move our head around up and down, the fluid actually stays more or less where it is, but the semicircular canals move around with our head. Now, there are little hairs pointing inwards in each canal in 3 different planes, which can detect movement. And that movement is relayed electronically through the vestibular nerve to the balance center in our cerebral cortex. Now, we can overcome the balance center, and it does happen occasionally. For example, if you were on a merry-go-round in a fun fair and you were whizzing around very fast, what actually is happening is the actual fluid in your semicircular canal is actually moving because you're whizzing around so fast. And then when you become stationary, the fluid in your vestibular canals is still moving, and that's why you can't actually balance correctly. Now, balance is seriously complex. It's not a simple thing at all, because your central computer system, your brain, which uses 20% of the energy of your body, has to have sensations from everywhere in your body. Throughout your body, you have sensory perception from your skin, and you have proprioception in all your joints and muscles and tendons, so that your body knows exactly where every single bone, every single joint, every single part of you, what it's doing right now. And what your brain does is it collates all this information, what you can see at the horizontal horizon, what you can hear, and in particular where you are in time and space in terms of your vestibular stimuli from your semicircular canals, and then keep correcting each of your joints, your muscles, your lumbar spine, all of the other joints, so that you keep, right now you're probably sitting in a chair. And that is actually very complex, because what is actually happening is your brain is actually sending nervous stimuli to the muscle fibers in your back and in your pelvis and in your legs and in your chest and in your arms and in your neck to keep you stationary by continually contracting and relaxing the muscle fibers. And that itself, just the contracting and relaxing muscle fibers itself, is seriously complicated, and we'll be doing that another time. But the whole business is really, really complicated, and the evolutionists want us to think that 3.8 billion years ago there were prokaryotic primitive cells which evolved spontaneously in the primordial slime, and amongst other things they developed balance. Absolute garbage. This is garbage of the first order. Balance is highly, highly complex. I don't think it would be possible to get a machine to replicate exactly what the human body does as we balance. So thank you for listening, and God bless you.